Okay, let's start. Today we'll talk about I/O. So the I/O is the input and output. Um, you can actually implement these functions by the standard C library. Um, it includes some function, which can help you to communicate with the CPU. You can use them by including some C library headers. So here are some examples. Most I/O functions they actually use this one, standard STD I/O. Here are some examples like Pucha means display a character to the screen. Getcha means you receive something from one character from keyboard. And we have a printf and a scan used to process a string, multiple characters. And then we have FO. They are used to handle some files. We also have the fscan, which read a formatted string from a file. All the character-based I/O in C is performed on the test strings. A string is a sequence of ASCII characters. They can be in a single file, stored in the file. They can be entered by a user through the keyboard. They can also be data structure stored in the memory. And then you can output them to the display. So the characters are processed in the order in which they were added to the screen. So the I/O library or I/O functions will not change the order of the character. So the standard input string is so-called output and PDL. The std in our command means the keyboard. So here is some example. The first sentence is display the character stored in the C variable. C is not a character. C is a variable in this case. And get char means you receive a char from the keyboard. So here are some examples. We declare the output the output H correct. The output the code as 104. So in many systems, the characters are actually buffered in the memory during the I/O operation. For example, you can use your keyboard to input a lot of characters. All of them will be stored in a buffer until you input a enter. They are stored in that buffer. After you click the enter button, the entire buffer will be input in the main memory. The data stored in the buffer will be sent to the main memory. So the characters are not flashed to output. This is for the output switch, which means that they will store the temporarily stored in the buffer and will not show on the output device until you actually add a new line. I will show you what's a new line character. So here is one example of the input buffer. We have four sentences here. The first sentence and the third sentence just print out a sentence. The second sentence and the fourth sentence will receive one character from the keyboard. So when the enter is new line to the string, and it is consumed by a second time. So this variable will be assigned, will be initialized as this new line. And here is another example for the output buffer. First, we display a character, and then we do some other operation. And then we display B, and then the new line. So A is actually added to the string before the delay, but the string is not flashed until the new line. So you will see nothing. You will see nothing on the screen. You will see the A and B in this new line simultaneously on the monitor. And then we have formatted IO. We use printf and scanf to enable the conversion between the ASIC representations and the inner data. So everything you input from the keyboard are the ASIC representation. And we can use these symbols to do the conversion. This is a integer. This is a floating point. This is a text. This is a binary number. This is a ASCII. This is a multiple character. The C is only one character, but the S indicates a lot of multiple characters. So the data you input from your keyboard is always ASCII representations, but by different symbols here, you can initialize different values. And some character cannot be represented by a single keystroke. Here are some. This is a new line. This is the backspace. This is a backslash. And then we will be special characters. Here is one example of the printf. First, we declare a lot of variables, including integer. And this is a string. This is actually a string because it's a array of array of characters. It's a string, and then we can have a floating point. When we do the printf, we need to specify the format. For example, if we want to print a, then we need to know that this is an integer. So we have to use this symbol. In this way, we can print number. Otherwise, if we give it a char, then the C language will automatically convert this integer to the char, to the ASCII char. It will give you, I don't know, some, it's a fixed ASCII character, not a random one, but a fixed. It will print out a ASCII code, ASCII character full value. And you can also print the A in the format of a hex, in the format of a binary. You can even do some computation here. So this sentence means you will print the sum of these two, the ASCII character. So in one sentence, you can also print multiple ones. In this example, you have three, one character, one string, and one double floating point number. So the first one is this chart. The second one is the string. The last one is the floating point number. So you have to, keep them in the same order. This symbol. If you switch them, then you will receive some warning. So you may make some mistake like this. The first mistake is that you have this symbol, but you didn't specify the variable here. This sentence indicated you want to print out a integer, but you don't actually specify the integer variable here. So in this case, this symbol will convert whatever is on the stack in the position where it expects the first argument. So it will give you some random number. And then we have the scanf. The scanf means it will receive some numbers, read some numbers from the stdin, which is the keyboard. And those numbers or those input have to match the format here. So here is one example. We declare the first one is we declare and then we declare the month, day, and year, three integers here. And then we have a double floating point, the GPA. So totally we have 5 variables. One of them is the array, which is string. And we can use this scanf to initialize these variables. By initialize, I mean you can actually input them, and then the value will be used to initialize these variables. So if you arrange you have to use the scanf in this. The first one is second one is integer. Third one is integer. Fourth is integer, and fifth is also a floating point, a floating point, double floating point number. And you have to use the quantity or the address of this variable, not the variable name, but the address of the variable. That's the reason why you have to use this symbol. Why you do not have the symbol here? Because the name is actually a array. So the first element at the beginning of this array is that function. So the name here is the function itself. So that's the reason why you can write the sentence like this. And the variable type match is these three are integers. So we have 3Ds here, and then we have indicated this is the double floating point number. Why you have to make sure the variable type match this symbol, because the scanf will automatically convert the data received from the keyboard to the data type. If you specify a wrong data type, then you will have a wrong result. And also the data argument has to be open. The return value of the function of a scanf is the number of successful conversion has been performed. So in this particular example, totally we have 5. If you run this sentence, this function gives you this one that indicates all of them processed correctly. But if you input something like this, then the return value will. Why? Because it can only have this one and this one. Because you don't have this one here, it will give you an error. Then only 2 are. Also, there are some mistakes, common mistakes you may make here. The first one is that you didn't use the quantity. It will give you some warning. And then you didn't specify the variable. After it receives a value from the keyboard, there is no variable to store that value. Also, this mistake will give you some random behavior. Will generate some unpredictable behavior because it will get the address from the stack. You don't know what's on the stack. So you can have more than one arguments in a printf or a printer or a scanf. So you can also check the declaration of the printf. The printf can support multiple inputs. And then we can also use the IO function to process some files. For example, open a file, read a file, and then modify content in the file, which means that you need to write something to the file. So the file is actually the application view the file as a sequence of ASCII characters stored on some device. So by a file, you don't need to use the keyboard anymore because it's difficult for you to input a lot of data from the keyboard. So you can read maybe a 10 gigabyte file by functions. So each file is actually associated with either input string or output string, or both. By this data type, you can declare a class to point to the file you want to open. And of course, this type is defined in this file, in this header. You can use the fopen to open a file. It has two arguments. The first one is the name or the location of the file. Name and the location. You have to specify the location through the name. And then the second one is the mode. Mode means either you want to only read or you want to write from the beginning. Any can you once the file is open, it can be read or written using the fscan or fcontrol. It's just like the scanf and printf. For example, you can print a file like this. This sentence means that instead of the monitor, you actually want to write this sentence in this file. After you run it, the file content can actually answer is this time. This sentence means you have in the format of this. So instead of input this from file, you have read and assign. Any question about this? You don't need. You don't want to. You don't want to modify the file. You don't want to view or edit. In this way, you can guarantee yes. Better OS. Or the runtime of the compiler. Or runtime of the language, for example. If you have Java, then it's GRE. GRE is Java runtime environment. It will manage the explicit list. So you never have free keyword in the Java. You just use the new object, and runtime will analyze whether you still need that object or not. If the runtime feel like you don't need it anymore, then it will do the garbage collection. No, you have to do that. So C you implicit list. You have to do everything by yourself.
The list is implemented inside the program that is being the implicit list.
You have to implement it yourself. The C has no list.
So if I use malloc,
yeah, you have to guarantee that right here.
So the malloc has access to that implicit list.
Implicit. Yeah. Okay. If no more question, we can stop today. Thank you very much. Yes.
So, for the final project presentation, it's like November 29. So it's not the last day.
So I will leave 1 week for you to do the project. So we have another class on Thursday this week. We will finish all the lectures. And then you have 2 weeks to do your projects. And then we can do the final project on these days. No, it's not on December 13th. Because I feel like in the last week, most students here. But if you prefer that, I can do that for you. Yes, if you prefer that. Okay, if no more question, we can stop it. Thank you very much.